Alright, let's read this problem. P of t represents the number of people. T represents how many minutes after the event started. Okay, there's 3 data points here, and it represents the first 6 minutes. Alright, and then this makes a constant rate, so it's in a line. We're going to make a line with this. And then after this happens, after the 6 minutes, people start leaving at 8 people per minute. So it looks like, if we look at this data, it looks like this data is growing. So you're going to have people coming in, and then they're leaving at 8 people per minute. Then it's going to start going down. Okay, we've got to keep that in mind when we do this problem. All right, so first thing I want to do is label the sides. This right here is minutes, and this over here is people. Okay, people in minutes. And I want to go, on the minutes, I want to go by twos. There's a reason. If I look at my information, I kind of see that twos is important. And on the people, I notice there's a 56 right here. Because I have 56 right here, I think that's about, it's kind of high. So I don't want to go by ones or anything. I want to make sense. I want to work. So I'm going to go by, let's say, 10s. So this would be 10, 20, 30, and so forth. All right, so here we go. Next, we want to look and plot the dots. So if we want to plot this one, 3 is 38. So at 3 here, we're going to go up 38, which is right about there. So let's put that 38 right about there. And then 4 is 44, so 4 would be up 44. So 4 would be somewhere around there. And 6 would be 56. So if we look at this carefully, you got to be careful because remember, you're going by tens. So this is 56 would be somewhere around there. All right, so those are my 3 values I'm given. And then after this, it drops by 8 per minute. So let's think about that. If we're dropping by 8 per minute, so at this point it's done, and we're dropping by 8 per minute. So let's see. If we drop 8 per minute, so let's take away 8 from 56. So at 7 minutes, 8 less of this is 48. So I would now be at 48. So at 7, I would be at 48. All right, and I drop 8 more, so then that would be at 40, and so forth. So we slowly be working our way down. What you'll notice is this graph would end up going down kind of like that, and this graph would look something like that. Now, those aren't perfect graphs. This is an approximation. Because I got my dots and made a line through it, this is also approximation. But there are going to be important values here we're going to have to pay attention to answer the questions in this problem. All right, so let's start now answering some questions. So the first question, at what rate are people entering the event? Entering is the red, so the rate would be the slope. So what's the slope between these dots? Now it's kind of hard because this is just kind of a sketch. Let's find our exact slope. Would it be easier to find between these two or these two? I think these two because the interval's 1, where this interval is 2 values. So let's find the slope of this. So m is going to be the change in y, so 44 minus 38, over the change in x's, which is 4 minus 3. And if I do the math there, that looks like I would get 44 minus 38 is 6 over 1, which is 6 people per event. Sorry, people per minute. I said that wrong. So this line is growing at a slope of 6. And we said earlier 8, this is at a negative 8 slope. So that's kind of important. Alrighty, looking good here. So again, this is people per minute. 6 people per minute. All right. Next question, how many people will be at the event at 5 minutes? Well, 5 minutes is right here, so it's somewhere right there, which looks maybe about 50, but we don't know for sure. Let's check. Now, this point right here, if we remember, is 44. 44 right there. So that's 44, and if I'm gaining 6 people per minute, well, if that's 44, what's 6 more than 44? Okay, if I had 44, and I'm gaining 6 more, because 6 per minute, that would be 50 people. So we want exactly, not just approximations. We can do exact because of the slope, the rate of change, and then the amount of people we had before. We could also take this number and subtract 6. But I think it's easier to add as we go up. Next question, how many people will be at the event at 8 minutes? So 8 minutes is right here. So you can kind of see it right there. Well, actually, if I did my dot right, that looks about 40. Did I do it right? Let's think. Well, let's see. If I was at 56 here, and I'm dropping 8, so 56 dropping 8. Okay, yeah, 56 dropping 8 is 48. Drop 8 again, that would be at 40. So how many people in 8 minutes? It would be 40 people. Cool. So I could do it by looking at that. Now, if you want to do it exact, not exact, we did it exact, but if you want to see the math behind it, we had 56 and we dropped 8 people twice. And when you do the math, that would give you 40 people. Because you started at 56 right here, we dropped 8 and 8 again. That would be the math behind it. All right, at what time would there be 32 people at the event? So 32 people, here's 30, so 32 is right above that. If I look at my graph, I can kind of see, well, 32 people, does that look like at 2? And if I keep going across, does that look like about 9? So looking at the graph, by approximation, I should say at 2 minutes, I have about 32, and also about 9 minutes, I have about 32. So we're going to go with that 2 and 9 minutes, we have 32 people. Now, it might not be exact. I'd have to go and check the points exactly, but it looks about 2 and 9 minutes. All right, next question. At what time would there be 60 people at the event? Okay, so wait, that highest there is 56. So 56 is the highest point, so will we ever have 60 people? No, the graph never reaches 60, so that's a trick question, if you want to call it that. This is never, it will never happen. So you have to watch out for that. Sometimes problems or ideas don't make sense. It's never going to happen. If we look at the next one here, how many people came to the event? Okay, there never was 60 people. Well, wouldn't the how many people came to the event be the most people ever? So the most people is right there, which was at 56. So that would be 56 people. All right. Next question, after how many minutes was everyone gone? All right, everyone gone would be 0 people. So whatever this is. Now I got to make sure my graph is accurate to find that. By looking at it, it looks like, okay, it's hitting about, that'd be 10, 12, 14, either somewhere between 10 and 14. So we got to think exactly where that is. So let's find it exactly. All right, and here's an easy way, or a way to do it. If I know I have 56 people here, and I'm dropping by 8 people per minute, let's take the 56 minutes and divide it by 8. That tells us how many minutes it would take to lose everybody. So if I take my 56 people and divide it by 8 minutes, you should notice that becomes a 7. All right? So if that's 7 minutes to get from this point to that point, and at this point, if that's 6 minutes, what's 6 minutes and 7 minutes later? So I have 6 minutes and then 7 minutes later, so I have 6 minutes plus 7 more. Does that look like 13 minutes? So that would be your answer, because at 13 would be when you are having 0 people left. Everyone's gone after 13 minutes from the beginning. All right, next question. What is the domain and range of the situation? Domain is the x values, so from here to there. Now, again, we just found that point exactly as 13. We were wondering by that graph wasn't perfect, but that does look like 13, so I actually graphed it pretty accurately. So I went from, it was a 13-minute party. So my domain would be from 0 to 13, or you could kind of say 13 minutes. My domain is 13 minutes, but I would prefer you put the interval from 0 to 13, or you could say it's a 13-minute party. Next is, what is your range? That's your y value. So how high did this graph go? So that's the highest value from, and it went from all the way down to 0 people in this scenario. So my range would be from 0 people to the height of 56 most people. Or you could say there are 56 people. Your range would also represent there are 56 people in the event. But again, this is a proper notation for range and domain. These are just kind of interpretations of it after you're done. Okay, here comes kind of the harder parts of the problem. I want to make my piecewise equation. All right, so 0 to 6 here is the first graph. That's the red one. Now, I want to get the equation of that. Well, I already know the slope of that is 6. So I know for the equation, I know I'm going to have a slope of 6t. Slope is 6. The problem here is, what is my y-intercept? Remember, in the equation is mx plus b. That's your m. I need to find my b, my y-intercept. So I need to find out what exactly that beginning point, how many people there are there. Now looking, it looks about 20. But we need to find exactly. So let's do a little bit of math first. We have to think about this. If this is shrinking by 6 people each time, and I have an interval of 6 times, so if I have 56, and I'm shrinking by 6 times, so let's think about that. If I have 6 times 6, that would be 36 people shrink. And I'm taking that away from 56. So I'm taking 56 to start with, and I'm subtracting 6 times. 6 times is 36. So what's 56 minus 36? That looks like it would be 20. Okay, so which looks right. Oh man, my graph is nice and clean. 20 is perfect. Looks like right. Awesome. So that would be plus 20. That right there is my slope. That is my y-intercept for the red graph. That's a little tricky. You just had to work your way back again to the y-intercept. Now, the next one is blue graph. Same idea, but this one has a negative 8t slope. The problem is your y-intercept's a little bit trickier here because it's way up here. So we have to think, okay, if I go way up here. Now, if we're subtracting 8 over and over, aren't I adding 8 6 times? So what is 6 times 8? That would be 48. 6 times 8 is 48. So what I'm doing is I'm adding 48, I'm an 8 to 56. So 48 plus 56, you should notice, if you do 48 plus 56, you would get 104. So that is your y-intercept. It would hit at 104 up here somewhere, and that's your slope. There's our equation. A little tricky for your equations. You just have to understand there's an equation here for the blue, and the red one is right there. Last piece, the interval. Well, what's the interval of the blue graph? Well, it's from 6 to, where did we hit again? We hit at 13 minutes. Okay, so that goes from 6 to 13 minutes. And we are now done with this problem.